Welcome to the first lecture of the Applied Quantitative Investment Management course. This is something that I'm incredibly excited about, and this first lecture will just set the right perspectives and show you how you can set up your Python environment such that you can work with the code that follows with the book, because this is an important and integral part of studying the material. Alright, so first on the agenda is to talk about how this course is different, and this is basically going through the preface of the book. I think this is also important just for you to set your expectations and just understand why it is that I am so critical of the mainstream finance and economics theories that we have today. Then we want to introduce the investment framework and some of its core methods, which basically corresponds to chapter 1.1 in the book. And then finally there will be some comments about preparing for the next lectures, and at the very end we will see how we can set up a proper Python development environment so that you can work with the code in a flexible way. Alright, so here initially is just about my experience, and it's not so important about the actual jobs I have. It's more important for you to understand how I came from a traditional finance economics background to be very, very critical of the things that they teach at universities, and basically just using mathematics to analyze the world as it actually is. So I have a traditional finance economics background, and during my bachelor's I also studied most of the theory quite uncritically. But when I finished, I had some sense of that, at least this micro and macroeconomic courses that I had, that it probably will not be that useful in practice. But then I thought that it's just because I didn't study them at a high enough level. So I was not really critical of this theory yet, because I trusted in the authority that universities they have when they teach this material. So actually I remember during the first semester I was even biking home from university thinking about what my indifference curve between beef and chicken was. So this was peak naiveness. The thing is, then I started at my master's, where I took the first more advanced macro course, which promised in the book that they will link the macroeconomy with the investment markets. And this part I was very, very excited about. The mathematics become more sophisticated with dynamic programming, Bellman equations and things like this. But actually, after studying this course for an entire semester, I realized that it also was not that useful. In fact, I had the opportunity of canceling my exam registration 1 week before, because it was an exam without any notes or anything like that. So you just had to sit down and memorize this material and then go 3 hours to the exam. And I decided I want to spend my credits on something more useful than this macroeconomic course, and basically something that has to do with mathematics and programming and things like this. So that's also one of the things that during university I was a teaching assistant in mathematics, statistics and econometrics that also involved a lot of programming. And basically I think that is the most useful things that you learn at universities. Some of this stochastic calculus and theory about derivatives pricing and things like this is also useful, but you don't really understand what derivatives are before you actually work with them in practice. And this is just a general point I want to make, that no matter how much you study at the university, there is nothing that can replace practice, because you don't really understand the issues before you have felt them on your own body. So this was my experience when I started working at Nordea Markets. That was my first job, where I would be working with equity derivative strategies. So basically I would write software that could analyze both discretionary and tactical equity derivative strategies. And this is where I got all the real world perspectives that I will also share with you in the portfolio construction and risk management book. However, I always wanted to work with investment management. So once there was an opening at Danske Bank Asset Management, I switched to that, where I work with tactical asset allocation and strategic allocation and portfolio construction. So here immediately I also noticed that although I at my university studied a lot of covariance matrix estimation, a lot of intraday volatility estimation, many gauge models, and a lot of mean variance optimization, Black-Lederman and Bayesian portfolio selection, I could see that these things were not really useful in practice, because we would always be concerned about what would happen in the tails. So, how would our portfolios and different elements in the portfolios react when we have significant market sell-offs? Because this is basically what people, they define as risk. It's the scenarios where you lose something compared to all deviations from the mean, which variance and this covariance-based approach is focused on. So this is where I started to develop this investment framework and the methods that I have now spent almost 10 years trying to perfect in close correlation with institutional investment managers. And I would also say that early versions of these things have been used successfully by myself to manage very complex multi-asset portfolios that include derivatives and leverage and all of these things. So for 4.5 years now, I've had this company called Quantitative Technologies, which basically builds the core of our functionality of this investment framework and method. So they run in a fast and stable way, and they're documented, tested, and all these things. And this part, it requires a lot of work. So basically in the book, you will see some still fairly basic examples so that you can understand what happens in the mathematics. So this is the most important part, but you should not expect that the book's code, that you can just take it and use it in production. At least there are no guarantees given in this way. This is just so you become comfortable with the methods. Then the production quality implementation is still, it's an entirely different course, I would say, because it requires a lot of specialized software engineering, a lot of numerical analysis, a lot of installation work and things like this. But if you, after this course, feel comfortable with the mathematics and you understand, what actually happens in these different algorithms, that's the best outcome that you can get. All right. So again, coming back to some of my critique of this finance economics theories. As I say, the mathematics for this derivatives pricing and all these elements, it's actually something that is used in practice. So if you learn something about that, for instance, I used this Topia local volatility model, so it was nice that I knew from university what it was. It was also nice that I knew this risk neutral pricing and how this martingale pricing theory is. That part I think is useful, is okay. But what you learn in terms of investment theories, so this KPM, mean variance, all these things, I think that does more harm than good. And one clear indicator of this is when you look at the Renaissance Technology. So this is the late Jim Simmons, who was the founder. And this is probably one of the most successful quantitative hedge funds that have systematically generated very, very good returns. They care a lot about hiring good scientists. And somehow they came to this conclusion that they will not hire people with traditional finance economics backgrounds and just focus on mathematics and physicists and things like this. So I still believe that even though you come from a mathematics and finance background, you can still be a good scientist, and I also see some people who are, but you have to somehow escape the indoctrination, because this finance economics theories, they are presented as if they are laws of nature without any disclaimers that when we actually test it against reality, it's very, very unrealistic. So if you have this traditional finance economics background, my best advice is to take the mathematics, take the programming skills that you have, and then look at what are the actual problems in the real world, and then try to solve them with all the nuances that there exist. And this is basically what this book tries to do. And the issue with this finance economics theory as it is now is that it's exactly wrong. in the sense that they make many fundamental assumptions very carelessly, and assume as if it's like gravity or something like that, and then they are very specific in the details, and this is what creates the illusion that it's actually very scientific what they're doing. But I would say that it's anti-scientific and pseudo-scientific at best, because scientific should be that we look at the world how it is, and then you try to model it, try to explain it, instead of making a wishful assumption about how we wish the world would be, and then try to analyze it in this area. So you could also say that it has finance economics academia right now has a very high bias and a very low variance. So basically they do analysis in the same narrow space, which fundamentally is wrong. So that's what we want to avoid. What we want to do is to say that at least our starting point should be fundamentally right, and then whenever it's necessary, we can still allow for approximations in the details and then be approximately correct. So this is what you will see with many of the methods that we have here. For instance, when we use entropy pooling in a sequential way, when we use portfolio resampling, and other elements where we allow for approximations in details, but the foundation is good, is solid, so it can still give us some useful insights in reality compared to what you usually see from university textbooks. All right. So this is a graph that I'm almost known for showing, just to summarize what's the big problem with mean variance, Black-Litterman, and all these variance-based approaches. And the fundamental problem is that reality, here you see the blue curve, this is S&P 500 returns since the year 2000, and the orange curve, this is the best possible normal calibration. So this is if we know the mean and the variance exactly, this is the best fit that we can do. And you can see that scenarios where you lose 40 or 20% have happened much more frequently historically than this nice bell-shaped curve will predict. So basically, since these scenarios are what we define as risk, then of course just ignoring them and building our portfolios on the assumption that these do not exist, and of course you can use a t-distribution or something like that, which have heavier tails, but it's still this very nice bell-shaped curve, which reality is not, then we can be in for a lot of trouble. So this is what we want to avoid. What we want to do is try to model these tail risk scenarios as accurately as possible, and we want to have methods that can actually handle optimization, analysis, stress testing of these fully general distributions. And of course there's just this more philosophical question of what is investment risk. Is it all deviations from the mean, or is it these loss scenarios? And I'm sure that when you ask most people, they will say it's the big loss scenarios, and actually they want this upside volatility. So that's also one mistake we want to avoid. All right. So instead of focusing on the mean vector and the covariance matrix, which university academics, they do a lot, and which I also did during my education. So I studied actually all these things quite extensively. And it's only once I try to apply them in the real world that I start realizing that they are not really useful. So instead of having these elliptical distributions, we want to have fully general Monte Carlo scenarios. This could also just, in the easiest case, just be historical scenarios, but ideally we want to use the history and then generate something which is not just the history, but has the same characteristics as the history. Because we know, of course, that history will not repeat itself exactly. That would also be a naive assumption. Anyway, so here we have this matrix R, which basically along the columns contains a simulation for our instruments. So this could be like Google, Facebook, Apple, and our risk factors such as interest rate and implied volatility surfaces. And then along the rows, we have joint scenarios for these risk factors and instruments that we can invest in. In addition to that, we can assign a scenario probability to each of these joint scenarios that we collect into a matrix called P. And since the elements of P are probabilities, we must require that they are positive and that they sum to 1. So we have this requirement that it should be greater than 0 because, of course, there are probably an infinite number of scenarios that cannot happen for the instruments that we invest in, and we don't want to be carrying around on these all the time. But as you can see, this is much more general, much more flexible than just an elliptical distribution characterized by the first two moments, which is the mean and the covariance. So this is the first way that the book is different, and this is also explained in section 1.1 in the book, where there's a summary of all the methods. And this is the next thing that we will try to do. So here, for you just to understand this market representation a bit better, we have a multi-asset portfolio with some bonds, with some equities, some even private equities, some hedge funds. And here we actually also include a put option on this equity index. So here the price of the put option relative to the notional is something like 1.87%. So you can see that in a scenario where these developed market equities, they increase a lot, well, then we lose the entire premium, while in a scenario where these developed market equities, they fall by 20%, then we get the intrinsic value of the option minus the price that we paid. So this option has a strike, which is 10% out of the money. So yeah, hopefully when you look at these different scenarios, this is what this matrix R could look like. And here we have an illustration of what these different probability vectors could look like. So here in this P, initially in our simulation, most of the time it would just be uniform because it's the risk model that decides how frequently different scenarios happen. But we can assign non-uniform probabilities to these scenarios, and this is what you see in this vector called Q. When we assign these non-uniform probabilities, it usually comes from using a method that is called entropy pooling, which has this formulation. So basically it's a minimization of the relative entropy with some constraints on the posterior probability vectors. So here this X, they represent probabilities that we determine through this optimization problem. So of course they must sum to 1. When you see this at first, it might seem very abstract, very complex, because you don't know what this G and H and A and B matrices and vectors they represent, but this is something that we will study very, very, very carefully throughout the course so that you understand all these elements. But basically, you can take this matrix R and then you can specify views on different functions of that, such as the mean, variance, skewness, kurtosis, even var and c-var, and then you can implement views in this way. So this relative entropy minimization, or in the case where these prior probabilities are uniform, it corresponds to entropy maximization. It's actually a theory which is quite well established and studied in other fields, but since finance economics academics, they focus so much on the mean and the covariance matrix, it's not something that you learn about at universities. But in other fields, it's a well-known and very, very powerful method that we will use in many ways. So my recommendation is that when you study section 1.1 is try to really understand what is this relative entropy minimization, because we'll be using it for many different methods throughout. Okay, so you can also think about this entropy pooling as a generalization of this Black-Lederman method, which requires make some assumption about CAPM. It focuses on the mean and the covariance matrix. It has this interesting tau parameter. It even introduces some logical inconsistencies in the edge cases and does not perform a proper Bayesian update. We have this method. But throughout the book, what you will see is that entropy pooling is so much more than this Black-Lederman. It's not only just a generalization that works for fully general distributions, it's actually also a method that we can use for simulation and in other clever ways that you will see. So just to give you a sense of how entropy pooling is used in the base case, it's basically if we have some simulation. This is for developed market equities. This is just log normal, so it's still very, very basic. We can adjust that distribution by giving it, let's say, some more left tails, or adjusting the variance, the mean, all these things. And then the power comes from us adjusting the joint probabilities. So basically here we only implement some views on, let's say, developed market equities, and we introduce fatter tails for them. But then entropy pooling tells us that if we are to respect the dependencies we have in a prior simulation, then high yield will also have fatter tails unless we specify specific views that they should not. So this is where the power of entropy pooling comes from, because it gives you updates for fully general distributions in a predictive way. So even if you in your simulation have many complex risk factor simulation, derivatives, P&Ls and things like this, all of this will just follow immediately, because it is this equivalent probability measure change in essence. So that's another perspective for you to understand what this relative entropy minimization actually is. So as I said, there are many clever ways of using entropy pooling. And the first thing is to, instead of using it in the base formulation that we have, to use it in a sequential way, because you then just get lower relative entropies with the same constraints. So this is something that you see here on the left, where if you just use the entropy pooling as originally suggested, you get this blue result that doesn't look like realistic compared to the prior, and also has a very low effective number of scenarios. You will learn what this effective number of scenarios is in the future, but usually we want to be as high as possible when we implement these views, because it measures how much we distort the prior simulation that we have. So here you see the results for the original entropy pooling and sequential entropy pooling, just implementing the same views, and we get a much lower relative entropy, in this case, and a higher effective number of scenarios. So obviously it makes sense for you to use the sequential processing, because it's almost like just you can think about an optimization problem where you just stop before the optimum, and then that would be silly to do if there's an algorithm that can actually get you even closer to that part. With sequential entropy pooling, there are also some views that you can implement, which the original method simply cannot handle. And there's here one example of a tail risk diversification fail scenario. This is something that we will talk a lot more about later in the book, when we start talking about risk management and tail risk hedging and a clever approach for doing that. So here I just go to another application of entropy pooling that you can do, is by having this causal predictive views and stress testing. And this is basically actually trying to take your hypothesis about the macroeconomy and translating it into P&L in your portfolio. So here we just specify some Bayesian net that says it's the economic growth that drives everything. This is still an oversimplified assumption. It's just the one that we use for illustration and testing, and then we translate it into the main risk factors in our portfolio, which is the equity risk premium, break-even inflation, and real rate. And then entropy pooling takes these views and hypotheses and implements them to project them over potentially a very, very complex simulation that you have. You will learn a lot more about this method in chapter 5, but here is just an example of some of the analysis that you can do. So you can see here in this case, we just have a low risk portfolio which has roughly 25% in equities and then the rest in bonds and alternatives. And we implement a stagflation plus rate hike view. So this is basically where we condition in the Bayesian net that growth is low, inflation is high, and the central bank still decide to increase the interest rates. This is the scenario that most investors, they are worried about. This is where most portfolios will lose. And you can see that the portfolio's return distribution shifts to the left, which makes sense. But even more interestingly, you can use these posterior probability vectors to also analyze the joint scenarios of your bonds and developed market equities. and actually see, okay, what are the joint tail risks if I want to equip this portfolio with a tail risk hedge? How can I do it in a clever way instead of just outright hedging of the equity risk, because this is usually expensive, which is also something we will see in chapter 2 about stylized market facts with the volatility risk premium. Okay. Another thing where entropy pooling can be used is for time and state dependent resampling, where basically we have some historical observations. We can introduce some exponential time decay if you want, and then we can condition on how likely these scenarios are when we use resampling. So here you can see that scenarios with some medium volatility, some low volatility, and some high volatility. And in this case, actually, it will create a Markov chain implicitly that we can sample from and generate very, very high dimensional market simulations. So this is an approach that we call time and state dependent resampling, and there's a specific implementation that we call fully flexible resampling. It's also something that you will learn about in chapter 3, but you can of course also start reading about it already. But this method under the hood uses entropy pooling to estimate these historical scenario probabilities. So once again, finally I stress that start to understand this relative entropy minimization and entropy pooling method as fast as you can, because it's very, very core and it's used in many, many different applications. All right, so then we come to the final step, which will be portfolio optimization. Compared to these traditional university textbooks, we don't want to do mean variance, because let's say that we have these very sophisticated simulations and they have nice tails, that we estimate them correctly. We don't want to, after that, reduce it to this elliptical distribution, which is what mean variance optimization effectively does. So we can still estimate the mean vector and the covariance matrix, and then when we optimize, we just ignore all the important nuances that we spend so much time working on getting right. So yeah, that's what we want to avoid, and this is why we focus on mean-CEVA optimization. The good thing about mean-CEVA is that it operates directly on these Monte Carlo simulations and probability vectors. So it doesn't matter how complex they are, mean-CEVA will give us meaningful results, and it will focus on the tail risks. So this is what we want to avoid. You also see that when we perform the optimization, we will do it over exposures, and this allows us to handle derivatives in a very, very nice and elegant way. And ideally, we also want to include some transaction cost in our self-financing constraint. So this is also different from the textbook, which just focus on portfolio weights. But when you have derivatives, portfolio weight is not really that meaningful, because many of them have weight 0. Let's say if you think about a futures position, market value 0, but of course some exposure, depending if you bought or sold the future. So to handle everything in an elegant way, we use a derivatives framework for portfolio management. It's also something that will be presented very carefully, and we put constraints on the exposures, and then we just have this self-financing constraint with relative market values multiplied by the exposures, and then everything sums to 1 still, and this is without loss of generality. So basically this constraint is just a more generalized version of this usual that market or portfolio weight sum to 1. And this is again something that when you are at university, when you don't really understand what these derivatives are and how to work with them, then you just think about these portfolio weights and it makes perfect sense to you. But then when you work with these things in practice, you will see that actually it creates a lot of issues for complex portfolios that use derivatives and things like that. All right. So just to conclude this introductory part is that all the methods that we present for analysis stress testing, they operate on fully general distributions and their associated probability vectors. So this is an important point, that this framework builds around these things, and this is because we want to be able to be approximately correct. So it's not trivial to generate this fully general distributions and the joint probability vectors, but it's possible to do much better than just from sampling from the normal distribution. So this is what you will see, that at least we allow some probability for being approximately correct, while if we use the normal distribution, it doesn't matter how precise we are in the details after that, we know that it's still exactly wrong. So this is the part that we want to avoid. And in relation to the things that we want to be able to represent in these fully general distributions, in chapter 2, so this is the next lecture, we will be going through some stylized market facts, where you can see that at least these are the core things we want to be able to capture, and then potentially there are also many other nuances depending on the markets that you invest in that you would know of, and then you can evaluate your simulations on. And then in chapter 3, so this is some lectures after, we will present what is actually this market simulation framework and what are the methods that we use to generate these fully general distributions. And you will see that it's more complicated than just estimating a mean vector and a covariance matrix, but it's still, if you understand the core parts, so this entropy pooling, the effective number of scenarios and things like this, it's still very feasible, and you can do it significantly better than just elliptical distributions. All right. So the last part for this first lecture is to set up a Python environment so that you can work with the code in a nice way. And this is an important part of studying the book, because many times I present the theory and then I show you the result of some case study, and then you actually need to go in and look, what are the details, and verify that you understand how these methods are used in practice. So it's not that all the details of the case study are not necessarily spelled out in the book. It just tells you high level of what happens, what are the results, what are the conclusions. For all the details, you will actually need to go and study the Python code, and I cannot stress this enough, that you should really read the book and then work at the code simultaneously, if you are to build a full deep understanding of all these methods. So here we want to show you how you can use Miniconda for package and environment management, and ideally through this Windows subsystem for Linux, because it's usually for Linux, most of the new cutting edge methods or packages, they come first, and then after that maybe they come for Mac and then for Windows. So of course we want to be able to use the newest method if necessary, or the best packages basically. Then I recommend that you use this Visual Studio Code as the editor, and then just Jupyter Notebooks for interactive computing. So all the examples are given in Jupyter Notebooks. And then finally, for version control, use Git and GitHub, which basically allows you to keep track of your code without making many copies, as I'm sure that some of you have tried at university, or maybe even during your work. Okay. So for the course, there's this GitHub repository where all the examples and then Jupyter Notebooks are, which is this Fortitude Tech PCRM book link, and this is something that we will just be going through throughout the course and showing you how to set up this Python installation. Alright, so here I have an entirely new Windows user, because I want to try to replicate how it is if you don't have anything installed on your computer. But of course, in your case, you can just use your normal user and then go through this process. So basically what we want to do is to be able to run Python through Linux using what is called Windows subsystem for Linux. And basically it's because most of the new cutting edge software is usually first developed for Linux, and most cloud servers, they run Linux. So this is why I recommend that you use it, even though that you have a Windows machine. The first step will be to install the Windows terminal, because it allows us to use this Linux machine in a nice way. And this is something that Microsoft recommends themselves. And then after that we will install Ubuntu, and then the Visual Studio Code as the editor from the Microsoft Store. So this is some time ago that I've done this myself, and if I make any mistakes, then I will correct them here live in this video, such that you can also see, if you run into them, how you can fix it. Okay, so the first step will be just going to this Windows Store, and here you can just search for terminal, and you will see that you have it here. So I have it already installed through my administrator profile, so it's here, but otherwise if you don't have it, just click install and it should run without problems. After that you can search for Ubuntu, and I recommend you just take the latest version, which is this one, search for this, and then just push get here. So then it will be installing. In the old days you had to go in and install this Windows subsystem for Linux manually first and then Ubuntu, but now everything should just be handled for you, so it should be a bit easier. So here you can say open, and then you have it in this Windows terminal already, and this will take some time. So basically here I will just cut until something happens on the screen. Alright, so now we just create a default account that we will use. I will just call it user, and then I will write some password, which should of course be very, very strong. Alright, and then the password is here running. So now basically we have this Ubuntu machine running in Linux. And if we just press ls here, we can see that in the home directory we do not have anything. So if we want to just check if it's actually running in a Windows terminal, we can go here and then start this terminal app. And then you can see that initially it will start in PowerShell, but you can push this drop down and then you have this Ubuntu machine here, so that you have access to actually this Ubuntu that you just installed. You can also, in the settings, if you want to use it as a default, you can just say that you want to use this Ubuntu, which one of them you want, and then so basically after this we should just be able to when we open the terminal, it should come correctly as this Ubuntu. So here you can see that you have this nice interface. So basically one good thing that you can do is just to check for updates and say sudo apt update. This is just getting the updates that have happened since that you installed this machine. And after that, if you want to then install them, you say upgrade. This is what we do here. All right. Okay. So I will just cut until this is finished and then come back. All right. So now all these things have been installed and the Linux machine should be up to date with just the default installations. So now we want to proceed to install this VS Code editor, and here an important point is that we want to install it on Windows and then use the remote access functionality to actually use our Linux machine. So here we just search for VS Code, but if you find it online, you should make sure that you install it for Windows. Do not try to install it directly on the Linux machine, because again, this is something that Microsoft, they recommend to do it in this way. So let's just follow the recommendation and then install it here. Alright, so now Visual Studio Code is installed and we will be able to find it here in our apps. Then the next step, we don't need this Microsoft Store anymore. We will now install on the Linux machine. So the next step is to install Miniconda on Ubuntu. And basically Miniconda, this is a small package and environment manager by Anaconda. Some people, they install this Anaconda distribution, but it includes many packages that you don't really need. So I just recommend going with the lightweight version and then finding the latest on this link. This link will also be given in the video description, so you don't have to write it off the screen here. So basically, we just go to this repository, and then we can see that for Linux, we have a latest version here. So for us to download this, we just right-click, and then we say copy link, and then we can go to our terminal here and use the command vget to download this version. And then you notice here on the right that you have this SHA-256 checksum. So just to verify that before you install anything, that it's the correct file that you have, and you can do it by checking this checksum. So I'll just show to you how you can do it in a nice way, because you can use this command sum, and then you have this Miniconda latest file. So in Linux, if you don't know, you can just type the first few letters and then press tab. It will try to find the file that you're looking for. So here that you can see that you get this checksum out, and you have this Miniconda. But of course it's very cumbersome for us to sit and verify this long string. So one of the ways that you can do it, which I think is the easiest, is by using this command, which is called grep, and then you just input this value that you're checking for here, and then if it's found in the output, then you can see that you have this red string. So let's say, for instance, that if we edit this one and remove a number, then nothing appears, but if it is the correct one, you have this red color. Okay. So now this Miniconda, it's basically the file that we use to install Miniconda. So the way that we can actually install the program is to use this bash command here, and then there's a license and you can read, and of course we don't have much choice than agreeing to these things. So let's see what happens. So basically this conda, so this is some config, we have to see what, okay, let's say yes just for this, just to make sure that everything in the background will run quickly. Okay. So now it just says that we have installed this Miniconda, but we need to actually restart this shell. So let's try to do that. Close the terminal here, and then you can see that we have this activated, the base environment. So basically in this Miniconda, it can manage different environments. So you can say conda env list, and then you can see that you only have the base environment. The base environment we usually do not touch, because this is where the package manager is installed and some default Python installation. So for each of our projects, we want to try to isolate the dependencies so that we can keep these environments quite lightweight, and that we don't have any unnecessary conflicts between the packages that we need. So this is the next step, that we will now try to install the environment for the portfolio construction and risk management book, and then just try to run some code. So we go here to our notes, and we find this repository. So here you can see how it looks, and then there are some instructions on how you can install it. So basically I created what is called an environment file after you clone the repository, where you can install all the dependencies. So I made it quite easy. And there's actually also a package on PyPy that you can pip install if you want to do it in some different way. But now we just try to use Git to clone this repository, and then install the dependencies, and then try to run some code to see that everything works. So basically with Linux you have Git installed already, but the first time we use it, we probably need to set up some information. So let's just try to do it when we clone this repository. Since this is a private repository and we are not logged in, we can just clone it here. So we go to code, HTTPS, and then copy this link, and then we say git clone, like this. Okay, so in this case, it doesn't even require us to set up our username or anything like that. But if you use Git with a private repository, then you probably need to specify your username and your email. And then you can also set up SSH keys, so you don't have to type in passwords whenever you clone it. And even from GitHub, it's only with SSH keys that you can actually clone and push to private repositories. So if you have issues with this, then please let me know, and I might make a video that shows you how to do these things properly. Anyway, now we have cloned this repository for the book, and you can use this command ls. So basically now you see that you have this Miniconda installer and you have this Miniconda installed and the PCRM book folder. You can, if you want, just remove this installation file. We don't need it anymore, so you can see now it's gone. And then you can just use this command cd PCRM book to get into this repository. So basically here you can see that there are some instructions for how you can install the environment. So this folder, if you push ls, you can see that it just contains everything as you see here in the repository in the same structure that you have. So here now we have access to this environment file, and we can install it like this. So yeah, this will take some time. Alright, now the installation is done, and if we want to execute code using this PCRM book environment, then we can follow the instructions that are given here by saying conda activate PCRM book. So this is what we will do here, and now you can see that this part changes to PCRM book. It indicates that we run Python from this environment. So if we then want to actually try to test out some of the code that follows with the book, then we can use this VS Code, and there's a clever way of doing it by just typing the command code, and then if you put a dot, it means that you will open the editor in the current directory. So let's try to do that. Okay, so first time, apparently you also have to allow this VS Code to run. That's good that we saw that. And then, yes, you can say that you trust the authors here. It's your own computer. All right, so now what you can see that we have also here on the left the same file structure as we had before. And we have this code folder, which for each chapter of the book contains some code. So for instance, if we open here for chapter 1, this is something that we'll be going through in the future. There's some code here, and then the way that you can test out that it actually runs, let me just zoom, you can do this Control plus just to zoom in. Here you can see that we have this Jupyter notebook already, and then VS Code says that it has an extension for Python. So it detected it's Python, and it asks you if you want to install it. I recommend that you do this. So this should be quite fast. Okay, and then there are some instructions on how you can get started, but let's just go back to this file. So here, what you can see is that we have this notebook, but we have not specified which Python kernel we want to use. So here, you should be able to find it, but then since it's this setup, then you also need to install this Jupyter extension, which something I forgot. But it's good that we did it in this video so that you know maybe you have this issue. Anyway, after installing this extension, you have this Python environments, and if you refresh, you should be able to find this PCRM. There is some issue here, but let's just try to close VS Code and then open it again. Because usually with time, then you will have that this code opens in the environment that you are. Okay, we say permanently allow here. And then when we go to this codes, okay, there's some Git also. Let's download that extension. This is for Windows. Okay. So that's on Linux, it should be there already. Okay. It tries to detect these kernels, and somehow it's interesting that it doesn't run here. Okay, so I think the issue is here that you want to have this remote extension. Okay. All right, so here, this was one of the common mistakes that I made, just to show you that, yeah, this is this is how you handle installation. So now, when we go to the code, it should work, where we could find this. There's another Python extension here. Okay, we can find Python environments, and now finally we can find this PCRM book environment. So now we can execute the code. All right, so I apologize for the confusion, but now you saw how you can handle some of these issues. So now you can run this code here, and then yeah, you can see everything will run nicely in this notebook, and you can reproduce some of the results that we have for the book. Okay, another way, just for the small examples, if you want, is just to run this code through Binder, but it's only recommended for examples that are not, heavy optimization and things like this, because these Binder servers are quite small and not always available. So here you can see that if you run this my Binder, then it will create an environment and then try to launch it for you so that you can explore examples in the cloud. But again, the disclaimer is that these Binder servers, it's not something that we are in control of, and they might change the distribution in some way so that it's temporarily unavailable and things like this. But in this case, luckily it works quite nice. So you can go into this second example, and then it should run already from the beginning. So you can see here, if you just push this control enter, then everything will run. Okay, if you experience any problems with the Python setup, then please let me know, and I will be happy to answer these questions.